Okay, welcome to lesson 4 in this advanced trigonometry section. Today we're going to move off the sine rule and start using the cosine rule to find the length. Okay, there's also a cosine rule, just like the sine rule. And the motivation for the cosine rule is that whilst the sine rule is amazing, as we've seen in the last 2 lessons, it occasionally lets you down. Because if you want to work with this triangle below, the sine rule won't help you at all here, okay? You couldn't find anything with it, because maybe you might call this C side A, but you don't know what angle A is. You might call this side B. You don't know what angle B is. And you might call this angle C, but you don't know what side C is. So I haven't got any matching pairs here at all, all right? Which is going to stop you from using the sine rule. For the sine rule, you need a matching pair. Luckily, for the cosine rule, you don't need a matching pair. It's built for these sort of problems. Here's the cosine rule, okay? It's in the front of an exam paper. You haven't got to memorize it, but you should do, because A, it makes you look cool, and B, it speeds things up. It's just A squared is B squared add C squared minus 2 times B times C times cosine A. See, it reminds me a bit of Pythagoras. Remember Pythagoras? Kind of like this here. But this extra bit here is needed, okay, because the triangle's not right angled. Okay, remember, because you could label the sides, couldn't you, of a triangle in any order you want. See, I called this one A here, but I could have called this angle B, couldn't I? And then now it'd be side B. Doesn't really matter. So there's other versions of the cosine rule. If you write these two down as well, you'll see a very simple pattern. All right, and the pattern is that the side here always matches up to the angle here. So you've got B here and B here. I've got C here and C here, and these two. All right, see, I've got B here. I've got the other two here and here. I got C here, I've got A and B here, and A and B here. Very important, okay? So make sure that's written down, because you're going to need it. And let's do an example, okay? So pause the video, draw this picture, and come back to me when you're ready to smash it, okay? Well, then, welcome back. Let's rock this example. I want to find angle X, okay? And normally, if I can, I'll use the first version of the cosine rule, this one here. So the unknown side I want to find, I'm going to call it side A. All right. So I call this A. Remember, this will be angle A. These are the two, it doesn't really matter. B, and that can be C. All right. So angle X is side A. So I'm going to use A squared is B squared plus C squared minus 2BC cos A. Put your numbers in. I don't know what A squared is, but B squared will be 4.2 squared. C squared is 3.7 squared. Take away. Now remember, 2BC means 2 times B times C, still multiplied by cos A. Now A is 110. I'll put it in brackets, okay, because the calculator is like the brackets for these trig functions. All right, now I would actually work out on a calculator this massive lump here, okay? So just leave the A squared alone and put that in the calculator and leave it on the screen. So 4.2 squared plus 3.7 squared, take away 2 times 4.2 times 3.7 times cos 110. It's going to be horrible. So leave it on the screen. I got 41.959, etc. Remember though, I don't want A squared, I just want A. So remember, to get rid of a square, just take the square root. All right, so on the calculator, okay, I would just do the root of the answer. All right, if you haven't got a scientific calculator, just leave this on the screen and just push the square root button. It should do it for you, okay? So when I do the root of the answer, I get that A is 6.48 centimeters to 2 dp is the length. And remember, this was actually called X. And with that, I'm done. Easy. Okay, example 2 then. Pause it, have a go. And then come back to me when you're ready to rock this maths, okay? Welcome back. So if I call this one A, B, B, C, C. I write the cosine rule down because you can decide y again in it. You want to find that side A it is, okay? So a squared equals b squared plus c squared take away 2bc times cos A. Substitute in. So 9 squared. This is easy, isn't it? 2 times 9 times 4 times cosine 53 degrees. Work this lump out. 9 squared plus 4 squared take away 2 times 9 times 4 times cos 53 close bracket gives me 53.669 yada yada yada. Take the square root. See what you get. I get 7.33 meters to 2dp. Easy peasy. Okay. So for the main task, there's only 4 to do. Shouldn't take you too long. So smash these questions and then come back to us when you need the answers. Okay, welcome back. There's all the answers here. All right, so make sure you mark what you've done. They're all the 2 decimal places. And then let's look at the checking question. All right, see you next slide, just so I can do a quick time check. Oh, I'm smashing it for time. But this checking question, okay, is very complicated. All right, so I pause this and then try and draw this picture, read it, and then come back to you when you're ready, okay? Right then, so alpha, beta, and gamma are 3 boats. I can see that. They receive a weather warning and need to go to Aberwin. I see that. The following picture shows where they are when the warning is received. Yeah, I see that. Find the distance of alpha and beta from Aberwin. Right. So, so the straight line distance. Okay. So I definitely need to know this distance here. Okay. This distance here needs to be known. So I might call this one X. Let me call that X a minute. And beta. And I also need this one as well here. I may call this one Y. Okay. So I definitely see triangles I could use here. Definitely see triangles I could use. Like if I'll try and squeeze it by here, but this may go very wrong indeed. Let's see what happens, is it? So what can I work out first of all? Well, I guess, yeah, I could do alpha first, couldn't I? Because I would use, I was hoping for a better highlighter there. It's better? Yeah. I will use this yellow triangle here. Okay, see, I can see this triangle. This triangle here, I'm good to go. All right. Because hopefully you spotted by now that to use the cos rule, all right, to use the cos rule. Oh, my pen's gone a minute, I think. Where's my pen gone? Oh, it isn't. Sorry, she's gone yellow, so I can't see it. Let me try again, Mr. Thompson. Right, that's better. Use the cos rule, remember? Hopefully you spotted by now. You see, whenever you've got 2 sides and an angle trapped between them, like this one, you can use the cos rule. Okay, so let me do X first of all. All right. Now, maybe you want to label these sides of this triangle. All right. So I will call this A here temporarily, which means that's angle A. I'll call this B, all right, which means this is angle B temporarily. And I'll call this one side C, which means that is angle C temporarily. All right. So again, A squared equals B squared add C squared minus 2BC cos A. And I may take a few shortcuts here, okay? So I don't know what A squared is. So it's 5.5 squared plus 2.4 squared, take away 2 times 5.5 times 2.4 times cos 76. Sorry, I had to go into 2 lines there, okay? I haven't quite got enough space. Hopefully that makes sense. So, all right. So if you work this out to get A squared, so 5.5 squared plus 2.4 squared, take away 2 times 5.5 times 2.4 times cos 76, you get that a squared is 29.62, etc. Take the square root of that, and you get 5.44 kilometers to 2dp, okay? And now, because I found that now, I'm going to get rid of that and the highlights a minute, I think. And maybe actually all these letters as well. Yeah, let me get rid of all this a minute, because it'll make my life a bit easier, I think. Yeah, I will do. Put a pen. So I know this one now, okay, it's 5.44 kilometers. I've done it. Right, so I've done that. Now I got to find angle y now. So I'm side y, sorry. All right, so I was hoping I could use the cos rule again, because the cos rule is pretty quick, but I don't think I can here, because if I'm going to call this one side A now, this will be angle A. All right, and I call this one, say, B, because I actually know it. Let me get rid of this y here. And now I can call this one B instead. And this would be C. And now it'll be C. I can't use the cos rule here because I got A. If I did A squared, all right, I'd have to do B squared add C squared, but I don't know what C is. So I'm going to struggle here, okay? All right. But actually, I can use the sine rule here from previous lessons, because I could write down A over sine A. I want to find A. I've got a matching pair, look. I've got B and sine B. So I could do B over sine B and use the sine rule, because it's probably a bit quicker, actually. Okay. So I'd have A over sine 32 degrees is B, which is, remember, B was 5.44. I just found it, over sine 118 degrees. And we know by now, don't we, remember to get rid of the sine 32? Just multiply by it. So A is going to be 5.44 over sine 118 multiplied by sine 32. And on the calculator then, so fraction 5.44 over sine 118 times sine 32 gives me the A is 3.26 kilometers to 2dp. So obviously, if you want to highlight the two answers, all right, you can. So if I try and highlight these, oh no, I won't do that. Oh, you get the point, didn't you? You get the point. I was going to try and highlight them, but will this work now if I try and highlight them? Because time is running out here. So A is 5.44, okay, and that was 3.26. If you have to specify which one was which, remember this A was a distance of alpha. So this one here, okay, is alpha. We have to make it very clear for the examiner. And this one here was beta. And that's a really hard question. So with that, we're done. Thanks for listening and watching, and I'll see you soon. Stay safe.